Good morning. My name is Gokul Mohan and my roll number is 28. Today, our group is going to present on the topic stretch forming process and deep drawing. Introduction to stretch forming. Stretch forming is the forming of a sheet blank with a rigid punch, thereby, a blank is rigidly clamped at the edges. A blank can be clamped between rigid tools corresponding to upper and lower drawing frame of the conventional tool or be clamped in gripping jaws. The explanations of these will be more likely understood when I move to simple stretch forming process. So, for understanding the basic idea of stretch forming is actually a metal forming process uh, for which it is used to produce metal sheets. uh, so we can move to the field of application. We all know that the stretch forming process is used to relatively obtain flat parts of large dimensions as single pieces, prototypes, or for small series. That is, we understood that the stretch forming is used to produce flat parts. So it is also really important for the production of parts of airplane industries as well as in our automobile industries. And there are also many other applications for this. So we can move on to different types of stretch forming. Okay, there are four types of stretch forming: simple stretch forming, tangential stretch forming according to Cyril Bath process, multi-sided stretch forming. So my topic is simple stretch forming, so we can move on to that topic. For a simple stretch forming process, the sheet sample which have to be formed is clamped between two gripping jaws located on opposite end. See, we can look at this figure. See, we can see two gripping jaw which is located opposite to each other, which locks the sample sheet. And the forming tool or block is fixed onto a tool table which can be moved hydraulically in a vertical direction. The tool table, as we see in this image, is this, and there is a form block which is above the tool table, which is powered hydraulically, and there is only vertical movement. And the force is necessary for the forming are transferred through the form block to the sample sheet. So when the force is applied, the force is transferred from the foam block to the sample sheet, which makes it stretch, and we get very light metal sheets. The part to be formed receives its contours during the motion of forming block. The gripping jaw remains stationary. As we understood in this image, the gripping jaws will be stationary, and there will be only the form block moving. And due to a large area of contact between the form block and the blank, the frictional forces prevent a deformation of the sheet in this region. Due to the frictional force acting between form block and blank, the middle region hardly undergo any deformation. That is the maximum possible straining capacity of the sheet is not attained. So we all know that the force will be below the maximum straining capacity. If it exceeds, we all know that it will damage the metal. So therefore, the deformation force is which is given will be below the straining capacity. So the sheet material flows under the tensile stress only out of sheet thickness, so that the surface of the sheet expands. Okay. In the figure, we can see that with the forces applied to the sheet blank, the thickness of the sheet will decrease, and we will get a larger the length of the sheet blank will be more, And examples of simple stretch forming is wing parts of airplane industry can be made by simple stretch forming. uh, yeah, so as I said earlier, the most of the aeroplane parts is actually fabricated with the help of simple stretch forming, and the wing parts of the aeroplane is uh, is actually fabricated with the help of this simple stretch forming. So this image shows us the example of simple stretch forming. It's just simple that we can make um, these kinds of materials, not materials. We can make this kinds of shape with the help of simple stretch forming. So that's all about simple stretch forming. Next is tangential stretch forming, which will be explained by Gregory James.
Hello, my name is Gregory James and I'm here to take a lecture on tangential stretch forming. On coming to the topic tangential stretch forming, it's a type of stretch forming process. The main difference compared to simple stretch forming is that both the foam block as well as the gripping jaws are movable in tangential stretch. Using this process, it is possible to subject the blank to a plastic pre-strain prior to the actual forming, so that the whole cross-section of the material undergoes a uniform plastic deformation. The process can be divided into two steps. In the first step, the blank is gripped by two jaws arranged opposite to each other. Then the jaws move horizontally away from each other and create a uniform plastic strain in the whole cross-section of the blank. In the second step, the foam giving block is moved vertically towards the sheet blank. Then the gripping jaws tilt and orientate themselves in the direction of tensile stressings of the blank, so that the blank, which is still under the constant tensile stress required for the plastic deformation, is draped tangentially over the foam block. Here is a tangential stretch forming pictorial representation in which there is a sheet blank which are supported on either side by gripping jaws which are facing opposite to each other. On below the sheet blank there is a foam block. Another advantage is that the application of an overlaid tensile stress to the workpiece during deformation reduces the residual stress. The reduction of residual stresses leads to lower spring back than in the case of simple stretch forming, so that the foam accuracy is higher and accompanied by a higher blister strength of the sheet part. Up comes uses of tangential stretch forming machine. So there are a number of uses. So tangential stretch forming machines are used to fabricate roofing arches for train coaches, then door frames and planking for buses, then planking parts for the aerospace industry, and planking parts for the outer covering sheets for cars. So here's an actual image of actual tangential forming machine. So we can see all the parts here. In the center part there is a sheet blank, and on either side there is gripping jaws facing opposite to each other, and on the lower side of the sheet blank there is foam block. So that's it. Thank you.
Hello and good day viewers. I'm Gokul Roshan P, and today we are going to discuss about stretch forming by Cyril Bath process. Now going into detail, the Cyril Bath process was developed by the Cyril Bath company. The process is based on the principle of tangential forming. In this process, it is possible to apply tangential stretch forming in a mechanical or hydraulic drawing press. The process is a combination of stretch forming and deep drawing operations. This process is used to fabricate large, relatively plain sheet shapes in small and large series. For example, car bonnets in our automobiles, airplane body parts are produced by Cyril Bath process. There are mainly 5 operational steps involved. The first step is clamping and pre-straining the sheet balance. The second step is drawing the sheet blank over the foam block. The third step is to apply a counter pressure. The fourth step is to move back the counter pressure equipment. And in the fifth step, Opening the gripping jaws and removing the sheet shape takes place. The figure for the previously stated 5 operational steps are provided. Now going into the operational processes in detail, the sheet blank is clamped between two gripping jaws facing opposite to each other. The grips are made to move away from each other to an elongation of 2% to 4%. Without reducing the applied stress, the gripping jaws are moved downwards so that the blank is wrapped around the foam block to produce a convex contour. The ramming punch is now moved downwards to produce counter pressure required for forming the concave contours. In order to prevent tearing in the overstressed region of the concave contours, the gripping jaws are moved horizontally and vertically in well-defined and controlled steps during the downward motion of the counter pressing punch. And finally, the punch is moved back to its original position. The jaws are opened and brought back to its original position, and now the sheet can be removed. Thank you.
Hi, I'm Govind Khyar and I'm here to take a lecture on multi-axial or multi-sided stretch forming. The multi-axial stretch forming process was developed to use the advantages of both the Cyril-Barth process and the tangential stretch forming process, and at the same time to eliminate the disadvantage of the two-sided stressing by arranging gripping jaws all around the foam block. In order to achieve these goals, the requirements listed in the overhead were set up. The gripping jaws should be able to be arranged around the sheet blank in order to increase the variety of shape types which can be produced. A segmented gripping system allowing optimal control of material flow and production of shapes with unsymmetrical contours should be used. The system should be able to enhance and adapt to fabricate convex and concave shaped parts. The process steps involved in the forming of shaped sheet patterns with a flexible segmented stretch forming machine are as follows. The sheet blank is fixed to the leading edge of the gripping jaws. The gripping segments are then moved towards each other so that the blank can be clamped in all 4 gripping jaws. The gripping segments then move apart, thereby pre-straining the blank. The vertical and horizontal movements are coordinated, making it possible to trace a curved path with which the blank can be drawn over the foam block. This you see right here is the diagrammatical representation of the principle of a flexible stretch forming system. The basic module consists of a gripping jaw which can be moved horizontally or vertically by means of a hydraulic cylinder. The gripping jaws can move 200 mm horizontally and 250 mm vertically. A further hydraulic cylinder activates the toggle lever sheet gripping jaws, whereby the gripping width is 250 mm. The total constructional height of a module is 1223 mm with a constructional length of 820 mm. The determination and programming of the path to be traced is decisive for both the forming operation as well as for the accuracy with which the contours can be replicated. Each stressing segment thus can be programmed to describe its own individual path. This can be achieved either by linear movement or by simple curves traced by applying small discrete movements directly to the supports. For foam blocks with complicated geometries, the travel paths must be manually predetermined using the part drawing as a basis. The fine adjustment is then carried out experimentally using an iterative method. 4-sided stretch forming using a hemispherical punch. The arrangement of the segments of a 4-sided stretch forming machine with a hemispherical punch, each of the 4 gripping segments can be operated individually. That is, each grip can be positioned and controlled independently. That's all. Thank you.
Welcome, I am Giftin Sam Benny of S4 Mechanical. I am here to discuss about the topic deep drawing. So let's start. First we can look on to the definition of deep drawing. Deep drawing is a forming process which occurs under a combination of tensile and compressive conditions. It is actually a manufacturing process where the workpiece is formed into desired geometrical shapes, for example kitchen sinks, cups, containers, etc. Now let's discuss the detailed process of deep drawing. Firstly, a round sheet metal blank is placed in between the blank holder and the circular die opening. Here blank means the workpiece we are using. As you can see in the figure 5.18a, the darkest shaded portion is the workpiece or blank, and it is placed in between the blank holder and the die. Then a punch is allowed to move down to force the blank into the die cavity to form the cup shaped product. This is the basic process of deep drawing. Then as the punch begins to move downwards, a bend is created over the corner of the punch. As you can see in the figure 5.18b, as the punch moves downwards, bend is created at the corner position of the die and the punch. It is well shown in the figure. As the punch moves down, the material also moves down and straightening takes place. During this process, there may be chance that in the workpiece for wrinkle to occur. Wrinkle here means a kind of folding on the surface of the workpiece. This can be prevented by applying a force over the workpiece. As you can see in the figure, the downward arrow on top of the blank holder shows that a force is applied over the workpiece, which helps to prevent wrinkle or folding. As the punch moves down, metal is drawn towards the die opening, which gives the drawing process its name, which means that in the figure 5.18a, the workpiece is at the leftmost and rightmost position, end position of the die. When coming to the figure 5.18c, as the punch moves downwards, the workpiece starts to move towards the die opening, which means that the workpiece is drawn into the die opening. That is why the name comes deep drawing. The word drawing comes from this process. The progressive downward motion of the punch results in a continuation of metal flow due to drawing and compression. Finally, due to compression and the force exerted by the punch, the desired cup-shaped product is formed as shown in the figure 5.18e. Now let's see what are the applications of deep drawing. This process can be used to make cup-shaped, box-shaped or any other complex-shaped products, especially hollow parts, etc. These are used in making kitchen sinks, cooking utensils, containers such as for food and beverages. It is also used in automobile industry for making fuel tanks, body parts, etc. The cylinders for fire extinguishers are made using deep drawing. Thank you.